This conference will now be recorded.
So guys, let's start writing regression model with the artificial neural network, right? We have the data set for cars.csv. So we'll be having these features on the basis of what we are going to detect the value of sales, right? And we'll be again doing the data pre-processing with the different algorithm. Last time we did see normalization and standardization, but today we're gonna do with the min-max scalar algorithmic approach. We'll see that what is that. So the first thing is I'm going to come up and read the data set. So I'll say data frame is your pandas dot read the CSV file. So this goes like cars dot CSV. Now we read the data set and I will be saying that there is something known as data set, which is your data frame dot values. So you read all the values and your x, which is your feature vector, right? It is going to be your data set of colon then 0 colon 5. So I'm just going to have 0 colon 5, which means the first 4 columns here. If you see now, so I got this 0, 1, 2, 3, and the 4, right? So 0 till 4. Fifth one is the sales. So what is this guy? Y? Y is your data frame of sales dot values. So it's very simple. So this guy sales over here is my Y, and the other part is your the first 5 column is your features, right? So I'll just come here and say print features. So this goes like printing the X, and similarly your target is going to be this guy called Y. So this is what we can see now, right? So the features and the target. So you got a lot of records here in the cars.csv. If you just wanna see that one, so I can print the data frame ones. So you got these 963 rows and 6 columns, right? And this is the entire data set available to us. Okay, so what is the next thing? The next thing is to understand that, okay, we have this Y as a target, but if you see this target Y, this is how it is. It's a list, it's a numpy array. And what I'm gonna do is I'm gonna print the shape of Y. Print me Y dot shape. So it's 963 and a comma, right? So what I will do next is I will say Y assign, let us say np dot. So I'll just come here and import the numpy. So I'll import few more libraries which I would like to use in my program. NumPy as np. So I'll even import matplotlib dot pyplot as plot. So this I'm gonna use in the end. Then I'm going to come up and import something known as so from your sklearn dot model selection, I can import this train test split. Then from your sklearn dot pre-processing, I'm going to import this min max scalar, and of course from TensorFlow I'm gonna import Keras to work on, right? So these are some of the libraries which we have imported. So numpy dot reshape this Y, and we want the shape to be -1 comma 1. So let us see what is Y now and what is the shape of Y now. So I'll just include one small print statement here. Reshaping y. All right, so here we are now, right? So what we got, y as array of arrays where each array is going to have one single value, 963 cross 1. Now, since we are done till here, right? So this was a bit of our features and target extracting from your CSV file. We would like to know what is this min-max scalar. So guys, this sklearn min-max scalar is already here, right? So how this min-max scalar transformation is going to happen? So your data transformation is going to be in the range of zeros and ones, right? So the transformation will be done by the formula x standard is x minus x dot minimum, x dot maximum minus x dot minimum divided by, right? And the scaled value will be your x standard into max minus min plus minimum, right? So minimum and max is going to be your feature range. Now this is the mathematical formula once again, right? So how we'll be doing it? So we are going to create a min max scalar. So in the min max scalar, you are going to fit the data which you want to normalize, right? And thereafter you say scalar dot transform the data, and you get the data in the range of zeros and ones. So let us try to see how it can be used here in our program. So typically, guys, I'm going to create a min-max scalar. So let us say scalar for the features. It is going to be a min-max scalar object. Then a scalar for the target, right? So I got these two different min-max scalar objects, and coming here, I will say scalar features dot fit the x, and similarly scalar target dot fit of y. So you are going to have this scalar that's like your array which is going to be created, right? And this is going to be transformed in the range of ones and zeros. So your x scaled data, right? So your x was the original values, but this is like zeros and ones, right? So we'll say x scale is your scalar features dot transform the x. Same way, y scale is going to be scalar target dot transform the y. Now let us print the transformed features, right? So transformed, or I'll just say, yeah, that's okay. Transformed features. Let us print this guy called x scale, and same way transformed target. Guys, what we are doing here, we are writing our entire code like this only, right? As in a script. But what you can do is you can always write an object oriented program. Okay, you can define the main, you can write the classes, you can write the functions, and thereafter you can do the processing. So I'm doing it just in a scripted way. So let's run the code here. So we'll see how the data transformation happens. So what we see now is, just give me a moment. All right, so transform features 0, 0, 0, and so on and so forth, right? So everything is between 0 and 1, right? Something is 1 and dot. Then the transform target is 4 point something, but into a 10 power minus 3 or minus 2. So that's gonna work in the same way. All right. So these are par in the minus. So if you see, so these are going to be in the range of ones and zeros only. So we got the first step done. So reading the data and pre-processing the data. So this is kind of your step one. So this is always right. So preparing and pre-processing the data for your neural network, right? So we would like to do these two things. So can I get a smiley from all of you? Is it good to go till here for everyone? What we have done so far is clear to everyone. Great, guys. So let's say X train. So next I'm going to say X train, comma X test, comma Y train and Y test. So this is going to be your train test split, but this time we're going to use the values X scale and the Y scale, right? So you're going to train your artificial neural network with respect to your X scale and the Y scale. So that's how we got the training and the test splits done for our model. So now moving ahead. So this is your preparing, training and testing data. So everything comes under this very step one, preparing and pre-processing the data. Step number two is your creating ANN model for regression. So we know for the ANN model to be, so we got an input layer, then we got hidden layer, and then we got an output layer. So guys, there was one query even. So how to come up and choose some number of neurons in hidden layers, or how many hidden layers we should be choosing, right? So this was one of the queries. But in order to solve this very basic statement for all of you, right? Because you will be working on different data sets, and you may not be able to find some, you can say, uh, solved solutions on the unseen data set if you're trying to solve them, okay? Now, input layer is always the shape of your data set, basically. For example, for me, when I say this X, right? So I can see that I have this 0, 1, 2, 3, 4, total 5. We have these input features. So my input layer, I need 5 neurons. And what should be the output for me? Output in this case is going to be only one single value. So I want only one node in my output layer, right? I don't want multiple nodes. So what can be the hidden layer? Ideally, hidden layer is any number of neurons in between the input layer and the output layer. For example, I can choose 4. I can even choose something known as 2. I can even choose something known as 3, right? But what happens is typically, so whenever I will create an artificial neural network, I'll be sure about my input layer and output layer. But even if you will choose any number of neurons the way you want, your ANN model will automatically do a process called filtration, where it will remove the unwanted nodes as in the number of epochs they are going to increase. So remember, please see the point here. So if we choose any extra neurons, so during the training process, with every epoch, it gets optimized and unwanted neurons or layers are removed. So we are very much kind of, you can say, sure about our APIs that they're gonna do the job for us. So other way around is what, right? So we can always try to increase or decrease neurons. So this is like where we can do that, right? We can always try to increase or decrease, number one, neurons, number two, hidden layers. Why? To achieve our desired result. So this is kind of hit and try. So this model also works with so many of the ANN models, right? You may not be able to calculate the hidden layers in a perfect algorithmic approach. So typically what happens is the algorithm, the more or less when you start training your model with the epochs, it's gonna automatically do that for you. So we kind of try to put the hidden layer in between input layer and output layer, but it is not very relevant to say. So you can anytime change this part. So let us try to write our program in a different way today. So I'm gonna say model is going to be your Keras dot sequential. All right, so I'll create this sequential model. Now I'll say model dot add. So in my very first layer, I'm gonna say Keras dot layers dot dense. I'm gonna add one a dense layer where I want 12 nodes, right? So I know my input features are only 5, but I'm choosing this guy as 12. But choosing this guy as 12 or 64 or 32 or 8 or any number won't matter for us, right? Because here your input underscore dimension asks you the number of features of your data set. So this attribute is quite important, right? Without this you cannot solve your problem, right? And the next part is your activation function. So this I'm sort of writing as rectified linear unit or ReLU. So guys, you put 12 here, you put 20 here, but this over the epochs is going to be automatically refined, right? So the next layer I'm going to add is hidden layer. Let us choose 8. So here we don't need any input dimension because it's not the input layer for us. We need only the input dimension in the input layer. So this is my input layer. This is our hidden layer. And last one is my output layer. So guys, for the output layer, I'm going to choose only one neuron because we know that for output there has to be only one value. And this I'm going to just choose as linear. I hope you can recall these activation functions. So rectified linear unit will give you f of x assign x for the positive numbers, not for the negative numbers, whereas linear it is going to give you for the negative numbers as well. So for my linear regression problem, so this is how we can create a very basic model, right? And what next thing I'm going to do is I'm just going to say print me model dot summary. Since you created your ANN model, you would like to see what is the model which you have created. So our ANN model. So let me run the program and see how this ANN model is created for us. And I'm gonna give you a small quiz as well. Okay, so guys, what you see is our ANN model is a sequential model. There is a layer called dense, then there is another layer called dense and another layer called dense. Now the concept over here is we see the shape the output shape is 12. So there will be 12 outputs from the first layer, and second layer is gonna give me 8 outputs, and the third layer is gonna give me 1 output. Now the point is, here we say parameter number is 72, 104 and the 9. So you need to explore what are these parameters. So how is this value coming out to be 72? All right, or how this value goes up to 104 and how this value goes up to only number 9. Okay, so Sahil says why we have not given test size and random state. Yes, we can do that. So there is a very basic query here. So in the train test split here, so guys, we got so many inputs. We got this guy called random state, right? So there was a query from Sahil that why we are not giving the random state or the other inputs. We can do that. So here we can just say random state is 0.2. All right. So guys, moving ahead now. So we created this ANN model, right? So once this ANN model is created for us, we are going to do a compilation on this ANN model. So I'll say model dot compile. I hope you can remember this step, right? So there has to be a loss which can be calculated through mean squared error, and this optimizer is going to help us in kind of, you can say, uh, optimizing our ANN model and the algorithm automatically for us, right? So fitting down these, you can say, neurons here and there. So matrix can be mean squared error and the mean absolute error. So typically for a linear regression, right, we calculate this, or for any other ANN model which is going to be a sequential model, right? So this is how we deal with it. So guys, when I say model is keras dot sequential, so this is an ANN with feed forward and back propagation model. All right, so this is sequential is what? Sequential is your ANN with feed forward and back forward algo, and dense is creating the layer the way we did see in our ANN as well. So next is what I'm gonna come up here and say your model dot fit. So I'm gonna write the fit function where we are going to say x train, and we got y train. So I'll choose some number of epochs. Let's say epochs are 25. Since you have a lot of data, right, I'm going to just say the batch size to be let's say 60. It can be any number. You can even choose a batch size of 100. It means that 900 records can be done in 9 times over 25 epochs. So guys, we can even come up and see, while you are training the model, you can even use this validation underscore split, which is the value 0.2. So when I'm doing this train test, random state as 0.2, right? So I can even say validation split over here. Now, whenever you will get this data train, so you will get a history once you train the model, right? So this is your compile the model. So guys, this is old discussion, and training the model, we will get a history object. I hope you can recall, right? So we already have discussed what is history when you train the model. So let us try to create one of the features, right? So X to be predicted. Let us create one feature here, right? X to be predicted. So let's say numpy dot array, and this is going to be an array of arrays. Let's say some number 40. So I'm using this cars.csv here. So we are going to be using some of the records here. So for example, this 40 guy over here. So let us say 40, we'll choose the value as 0. We'll manipulate these values somewhere and we'll try to see what is the output. But now in order to understand if the output is correct or not, right? So there has to be evaluation of the model. So this is something which I would like to predict, right? This is the data which I would like to predict. But if you wanna predict this data, so you need to transform this, right? So you need to transform this with the help of this scalar features. If you can see, guys. So fit function is already done here. So scalar feature dot transform, you have to do that. So I'm gonna say X to be predicted. Let's say transformed is your scalar features dot transform the X to be predicted, because your ANN model has been trained over this min max scalar algorithm, right? So what I will get is I will get predicted by. So y prediction predicted y will be your model dot predict, and you need to pass this guy called X to be predicted transform, right? So you get the value of y, but this y predicted value, it will be in min max scalar, that is range between 0 to 1. So if you want, we can do an inversion on the same. I can invert this normalization. So invert normalization, that is get the real value again. So how we are going to get that? So guys, y predicted is going to be your scalar target dot inverse transform the y predicted. And same way, so we have this X to be transformed. If you want, you can get it back into the real way as well, right? So I'm gonna just say print for X this prediction is, for X this prediction Y this, right? And we'll just say a dot format X to be predicted, comma Y predicted. That's what I'm gonna just do here. So let's run this program and see if we go through it. We don't have any errors here and there. Let's just wait for the program to finish. Okay, I think we have a query, we have a problem here. I have just given it 2 times. Just give me a moment. All right, so let's see. Here we are. So data set is trained, and what we get is for 40, 0, 26, 9,000, 8,000, the prediction is 1 to 196 or 252. Let us see this. So I got some record with the 40 from here. but I think we even manipulated this data here, right? 26, 9,000, 8,000. We'll try to get quite a similar value and try to now see what it can give us as result. So that was like unseen data set, right? And this is like the seen data. We'll just see what is the prediction coming up for us. So this is like 10318.14. This is like 6263, not closely matching, but this may happen. So what I'm gonna do is I'm gonna just see what is the loss and the prediction, right? I mean, we'll just see when we were training our model, right? How this model loss, was evaluated. So coming here, let us say print me history dot keys. I hope you can recall this, guys. We have seen the history model, right? So what we are going to do is we are going to plot the losses with each epoch in our ANN model. Okay, so I'm gonna say plot. So the first one I'm going to plot is your history of the loss. So you have this loss as a key in your history, okay? Then we even have something known as value loss. So these are all the keys which we are going to print. You can even use more of the keys if you have in the history. You can just plot the various different graphs. So the title for me is model loss plot. Okay. So let's say plot dot. So you have X label. So X label is the epochs. So as in our epochs, they went to 25, right? So how the loss was evaluated, right? So Y label is going to be your loss, the printed loss. So what is this loss? This is loss with training data, and this is your loss with the testing data. So when I say testing data, it means validation data. So I'll just give me a moment here. So let me just first of all finish this part. So let's say plot dot show. We'll see how this plot shall look like. So here we are, right? So the training and the testing. So this loss during our training part, it kept on decreasing, right? So even if you increase more number of epochs, your loss is going to be even more lesser. Now, what I will do, one more thing I'm gonna put up here in my model is what? So for this here, I'm going to say the label is training, and for this guy, the label shall be testing or validation. So I'll even say plot dot legend, so that you understand what is what. So training and the validation, right? If you see now a more better graph. So every time you train the NN model, of course, there may be something here and there, right? Because weights and all, they are chosen as random, and some things may go here and there. So rather than doing this training and test split part, what I'm going to do is I'm going to train my model directly on this X scale and the Y scale. Okay. So I'll say this X scale and the Y scale. I didn't divided my data set. So this data set will automatically be divided into the perfect training and test automatically. Now let us try to run the program once again and see what will be the outputs. So here we are, right, with a different part. So you need to always come up and see how you can deal with your data sets, right? So this was where we already divided the data set, and thereafter with the divided data set you are trying to train the model, and now I'm using my full data set and I'm using this validation split to do that. Let us now even not use the validation split and try to train our ANN model on with everything here and there, right? So with all the data I am training my ANN model. Yes, so if I will not give the validation split, so guys, I will not be able to get this plotting done. But what you see is, if you are not validating, if you are not dividing your data set, right, you are very much close to your value. So the original value was something like 6,000, predicted value is like 8,000. If you can see now, right? So it's all about your data set. The more the data set, the more better the results be. So the data sets are required to be in a better shape, in a better way, to get some better values. So let me share this program over the chat. Please give it a review and let me know if you have any query here. So please acknowledge me with a smiley in case we are good to go till here. So the next topic which I'm going to take up is something known as what is Flask and how we can use the same for your projects. So Shimpa, once the activation function is decided here, so it will remain the same. So your entire ANN model will be trained on the same activation function. You need to choose the activation function. You cannot dynamically change the activation functions. So this is kind of hardly fixed for us, so that your model will work on the same approach here. Yes, you can manipulate these activation functions if you want, but before you train the model, right, you have to make sure what activation function you're going to use. So guys, we'll be now working on Flask, right? But we'll take a small break of 10 minutes and we'll rejoin the session. Okay, so I'm just closing this session. So we'll rejoin the next session, the same link after 10 minutes, right? So 11:05. Thank you guys.